Airbnb Data Analysis, Exploring NYC Listings. Welcome to this beginner-friendly lesson on analyzing Airbnb data. We will use a real-life dataset of New York City Airbnb listings. You will learn important steps for loading, cleaning, analyzing, and visualizing data. By the end, you will know how to get insights from a real-world dataset. Let us dive in. Running the cell now. We start by hiding all warning messages. This makes your notebook output easier to follow. This command suppresses warnings that you do not need as a beginner. Import numpy as np. We set the random seed to 42 for reproducibility. A clean output without random warnings helps you focus on learning, not troubleshooting. Running the cell now. This code snippet sets up a clean and controlled environment by suppressing warnings and fixing the random seed for reproducibility. Notice how there's no visible output here. This is intentional to keep your focus on learning without distractions. This foundational step ensures that all subsequent code runs quietly and consistently, making your analysis smoother and easier to follow. What is Airbnb data and why analyze it? Airbnb is an online marketplace for short-term rentals and stays. The public dataset contains listings, prices, neighborhoods, reviews, and more for New York City. Learning to analyze such data is a valuable job skill for both students and professionals. Data analysis helps answer real questions, like: what is the most expensive area? How are prices distributed? Which neighborhoods are most popular? You will learn to answer these using Python. Running the cell now. Data setup. We load the Airbnb NYC listings dataset using pandas. We import Kaggle Hub to download datasets from Kaggle OS to interact with the operating system, and pandas to handle data tables. We download the dataset folder from Kaggle using Kaggle Hub and store the path. We list the files in the downloaded dataset folder to see what is available. We read the CSV file rayb_nyc_2019.csva into a pandas data frame named df. We print the shape of the data frame to see the number of rows and columns. We print the first 3 rows of the data frame to get an initial look at the data. Running the cell now. This output shows the initial overview of the Airbnb NYC dataset, revealing it contains 48,895 listings with 16 columns each. The sample rows highlight key columns like neighborhood_group, room_type, and price, which are central to understanding rental patterns across boroughs. This sets the stage for analyzing questions like the most expensive area by showcasing the structure and type of data we're working with. Mini exercise. Try changing the file name in the code to see if there are other CSVs in the folder. What happens if you print different files? Let us see what columns or features are available to us in this dataset. This command lists all column names, so you know what data you can analyze. Info tells you the type of each column, if there are missing values, and how many entries there are. This is useful for getting your bearings with a new dataset. Running the cell now. This output reveals the dataset structure, showing 48,895 Airbnb listings with 16 key columns, including neighborhood_group, price, and room_type. Noticing the complete and mostly non-null data helps us trust subsequent analyses on pricing and neighborhoods. Understanding these columns sets the stage for exploring questions like which areas are most expensive. Understanding the data columns. Here is what some important columns represent. ID, listing unique identifier. Name, title of the listing. Host_name, name of the seller. Neighborhood_group, major NYC area like Manhattan or Brooklyn. Neighborhood, more detailed local name. Latitude and longitude, location coordinates. Room_type, type such as entire home, apartment, or private room. Price, price per night in dollars. Minimum_nights, minimum nights required to book. Number_of_reviews, how many times reviewed. Availability underscore 365, how many days per year available. Knowing what each column represents helps make analysis more meaningful. Running the cell now. It is always good to find out if your data is missing anything before you start analyzing it. This command counts missing values for each column. High numbers may mean you need to clean or fix the data. Running the cell now. This output shows the count of missing values in each column of our dataset. Notice that columns like name and host underscore name have a small number of missing entries, but last underscore review and reviews underscore per underscore month have over 10,000 missing values, indicating many listings have no reviews. Understanding which columns have missing data helps us decide how to handle these gaps in later analysis or cleaning steps. We will quickly clean the data by filling missing host names with unknown. Replace missing host names with the string unknown to avoid null values. Remove any listings that do not have a price, as price is necessary for analysis. We check for missing data one more time just to be safe. Print the count of missing values in each column to confirm cleaning. Running the cell now. After filling missing host underscore name values with unknown and dropping rows missing price, we see that all key columns like host underscore name and price now have 0 missing values. However, columns like name and last underscore review still contain nulls, indicating some listing titles and review data remain incomplete. This demonstrates how targeted cleaning fixes specific data gaps while highlighting the importance of checking each column's completeness for future analysis. Your first insights, listings count. Let us answer some simple questions. How many listings are there in total? How many hosts are offering places? How many unique neighborhoods are listed? Running the cell now. We are counting the total number of listings in the dataset. This line prints the total number of rows, representing all listings. Here we count how many unique hosts are in the data. Finally, we count the number of distinct neighborhoods covered by the listings. Running the cell now. This output reveals that the dataset contains 48,895 total listings, offered by 11,453 unique hosts across 221 neighborhoods. Notice how these counts give us a sense of the dataset size and diversity, directly addressing our initial questions about listings, hosts, and geographic coverage. This foundational insight helps us understand the scope before diving into more detailed analyses. Let's explore some basic price statistics, the average, minimum, maximum, and median values. First, we calculate the average price to understand the typical cost. Next, we find the minimum price to see the lowest cost available. Then, we determine the maximum price to identify the highest cost. Finally, we compute the median price to understand the middle value of the price distribution. Running the cell now. This output summarizes key statistics for the price column, revealing that while the average listing price is about $153, the median is lower at $106, indicating some high price outliers skewing the mean. Notably, the minimum price is 0, and the maximum is as high as $10,000, highlighting the range and variability of listing prices. These insights help us understand the overall price distribution across the listings, an important step before deeper analysis. Visualizing data, price distribution. A visualization can quickly show how prices are distributed. You will draw a histogram, which is a bar chart showing how many listings fall into each price range. This helps you see if most prices are low, high, or somewhere in the middle. Running the cell now. This comment explains the goal, to draw a histogram showing the distribution of Airbnb prices, focusing on listings priced below $500 to improve visibility. We import Matplotlib's pyplot module, which provides functions for creating plots and graphs. Set the dimensions of the plot to be 8 inches wide and 4 inches tall, controlling the figure size. Filter the data to only include listings with a price under $500, then plot a histogram of these prices with 50 bins and a sky blue color. Add a title to the histogram to describe it clearly as the NYC Airbnb price distribution for prices below $500. Label the x-axis to indicate that it represents the price in dollars per night. Label the y-axis to indicate that it represents how many listings fall into each price range. Display the histogram plot on the screen so it becomes visible. Running the cell now. This histogram shows that most Airbnb listings in NYC are priced under $200 per night, with a steep drop-off as prices approach $500. Notice the tall bars on the left, indicating a high concentration of affordable options. This visualization quickly reveals the overall price distribution, helping you understand where the majority of listings fall within the lower price range. Small tip: try changing the number in a price less than 500 to a different value. See how the shape of the chart changes if you include more or fewer listings. Let us find out which major areas in NYC have the most Airbnb listings. This command counts up how many listings belong to each neighborhood group, such as Manhattan, Brooklyn, and others. You will see the most popular locations for hosts on Airbnb. Running the cell now. Here, we see the counts of listings in each neighborhood group, with Manhattan and Brooklyn having the most by far. This distribution is crucial because when we visualize price distributions later, knowing where the most listings are concentrated helps us interpret patterns more meaningfully. It sets the stage to understand how price trends might vary across these popular areas. Plotting listings by area. It is much easier to compare popularity visually. Let us make a bar chart showing the count per neighborhood group. Running the cell now. This comment explains that we are creating a horizontal bar chart to show the count of listings for each neighborhood group. We import the Seaborn library, which is useful for creating statistical graphics easily. We set the figure size to 7 inches wide by 4 inches tall for the plot. We create a horizontal bar plot using the listing counts, with colors from the pastel palette. We add a title to the chart to describe what the visualization represents. We label the x-axis to indicate that it shows the number of listings. We label the y-axis to show that it represents the neighborhood groups. Finally, we display the plot on the screen. Running the cell now. This horizontal bar chart clearly shows the count of listings across different neighborhood groups. Notice the varying lengths of the bars, which make it easy to compare which areas have more or fewer listings at a glance. This visual approach helps us quickly identify the most popular neighborhood groups without parsing raw numbers. Now we want to know which boroughs are the most expensive on average. Grouping and averaging prices per neighborhood group helps you spot trends in costs. The boroughs will be sorted from the highest average price to the lowest. Running the cell now. Here, we see the average price for listings in each neighborhood group, sorted from highest to lowest. Notice that Manhattan has a significantly higher average price compared to other areas, highlighting its premium market. This numeric summary helps set the stage for our upcoming bar chart, where we will visually compare listing counts by area to understand their popularity. This comment explains that we're creating a bar chart showing the average price for each neighborhood group. This line sets the size of the figure to make the plot wide enough to read easily. Here we plot a horizontal bar chart with average prices on the x-axis and neighborhood groups on the y-axis, using that summer color palette. This sets the title of the chart to describe what the plot is about. This labels the x-axis as an average price so viewers know what the horizontal bars represent. This labels the y-axis as a neighborhood group so viewers understand what each bar corresponds to. This line displays the completed plot so it is visible in the output. Running the cell now. The bar chart displays the average Airbnb price for each neighborhood group, making it easy to visually compare pricing trends. Notice how the bars represent the average price values on the x-axis, with neighborhood groups on the y-axis, highlighting which areas tend to be more expensive or affordable. This helps us quickly identify price differences across locations, reinforcing the lesson's goal to compare listings by area. Mapping listings, price and location. Visualizing listings on a map can be powerful. We can use latitude and longitude to see where expensive and cheap listings are. Scatter plots can reveal clusters and price hotspots. Running the cell now. This comment explains that the plot will show Airbnb listings by location, colored by price under $500 for clarity. We create a figure for the plot with a specific size of 8 by 6 inches. We select a random sample of 2,000 listings where the price is less than $500 to focus on more affordable listings. We make a scatter plot using longitude and latitude for position, coloring each point by price with a cooled color map and some transparency. We add a color bar to the plot to show how colors correspond to prices in dollars. We label the x-axis as longitude to show horizontal location. We label the y-axis as a latitude to show vertical location. We give the plot a descriptive title about what it shows: NYC Airbnb listings location and price for listings under $500. Finally, we display the plot on the screen. Running the cell now. This scatter plot shows a sample of Airbnb listings across NYC, with each point's position representing its geographic longitude and latitude. Notice how colors range from cooler to warmer tones, highlighting price variations under $500, which helps identify clusters of pricier or cheaper areas. This visualization connects location with price, making it easier to spot neighborhoods where listings tend to be more or less expensive. Try running this code again after changing the sample size to 500 or 5000 and see how dense the points appear. This is a great way to explore large datasets visually. We want to find out which room types appear most frequently. Here, we print the count of each room type in the dataset. Running the cell now. This output shows the distribution of the most common room types in the listings dataset, with entire home apt and private room being the two dominant categories. Noticing these counts helps us understand what types of accommodations are prevalent before we map their prices and locations, ensuring our visualization accurately reflects the market's composition. This foundation guides us in interpreting price clusters by room type on the map. This comment explains that the plot will show counts of each room type using a bar chart. This line sets the size of the figure to be 6 inches wide and 3 inches tall. Here, a horizontal count plot is created to display the number of listings for each room type, ordered by frequency, using a color palette named Set2. This line sets the title of the plot at Airbnb room types in NYC. This line labels the x-axis as a number of listings to indicate what the lengths of the bars represent. This line labels the y-axis as room type to clarify what the bars correspond to vertically. This line displays the plot so it appears in the output. Running the cell now. This bar plot shows the count of different room types available in NYC Airbnb listings, highlighting which types are most common. Notice the ordering of room types from most to least frequent, which helps us understand the supply landscape before mapping prices and locations. This overview sets the stage for exploring how room type distribution relates to price clusters on the map. Time for a mini project. Try these questions on your own code. 1. Who are the top 5 hosts by number of listings? 2. What is the median price for each room type? 3. How does minimum night requirement differ across neighborhoods? Pause the video and give these a try. When you are ready, continue for more visual fun and insights. Running the cell now. Correlation tells you if two features go up or down together. For example, do higher prices mean longer minimum stays? This table lets you spot relationships for further analysis. Running the cell now. This correlation matrix shows how 4 key features relate to each other, with all values close to 0 indicating weak relationships. Notice that price has almost no correlation with minimum nights or number of reviews, meaning these factors vary independently in the listings. This insight helps us understand which variables to explore further in your mini-project questions, like examining minimum nights or price patterns by neighborhood or room type. Try adding more columns to the list, such as a reviews _per month, if available. Correlation is a good clue for feature selection in machine learning too. This comment describes what the upcoming plot will show, a visual heat map of correlations. This line sets up the size of the plot to be 5 inches wide and 4 inches tall. Here, we create a heat map using Seaborn to visualize the correlation matrix with color coding and annotations. This sets the title of the plot as feature correlation so viewers understand what the plot represents. This line displays the plot on the screen so you can see the heat map. Running the cell now. This heat map visually highlights the strength and direction of correlations between different features in your dataset, with darker colors showing stronger relationships. Notice any strong positive or negative correlations that could inform which variables are most connected when analyzing listings. This helps you understand feature interactions before tackling the mini-project questions on hosts, prices, and minimum nights. Share your results and keep exploring. You just analyzed real-world data, made visualizations, and discovered trends. Try changing filters or columns to answer your own questions. If you enjoyed this lesson, subscribe to the channel and leave a comment with your favorite insight. There is much more to learn in data science. Imagine what you will create next. Running the cell now.